All right, the next system of equations we're going to work with is one where we see lots of decimals in the problem. I see that the coefficients of all my variables and my constants all are decimals in this situation. Honestly, I could just go ahead and work this problem through with the decimals, but the chances of me losing track or messing up on some of these problems is pretty high if I do that. So what I'm going to do is give you a strategy for getting rid of the decimals. What you need to do first is look at each equation separately. So first, just look at the first equation and see what is the most number of decimal places that you see in the problem. So here I see 1, 2 decimal places. Okay, in this second term I see 1, 2, and then the last one I see 1, 2. So this one just happens to be that they're all the same amount. So there's 2 decimal places in each one. What I'm going to do is multiply by a multiple of 10. Okay, so we're always going to be looking at some, like maybe 10 would work. If I multiply 0.05 by 10, I actually just get 0.5, so I still have a decimal. So what we're going to do actually is, because there's 2 decimal places, I'm not just going to multiply by 10, I'm going to multiply by 100. Okay, and what that does is that moves the decimal place 2 places to the right. Okay, so anytime I multiply by 100, I move the decimal 2 places to the right. If there had been 3 decimal places, I would have multiplied by 1,000, which would have moved the decimal place 3 places to the right. Okay, but in this situation, 100 will work. So I'm going to move each decimal place to the right 2 places. This equation becomes 5x plus 1y equals 9. Okay, so you might want to type that in your calculator to verify what I'm telling you. Okay, but we move 2 places to the right when we multiply by 100. Okay, that equation looks a lot nicer to work with than this one right here. So let's use the same thought down here on the next equation. Here I see in this first term that there's only 1 decimal place. Okay, but in the second one there's 2, and in the last one here there's 3. There's 2 again. Again, I got to pick the one that has the biggest or the most number of decimal places. So here, the 2 is what's going to win. So I need to multiply both equations by 100 once again. Okay? If they had all just had 1 decimal place, I could have just multiplied by 10, and that would have worked just fine. All right, so when I multiply by 100, I've got to move 2 decimal places. Even though this one just has 1, I still have to move 2 decimal places, and I've got to remember to put that extra 0 in at the end. So this is going to be 10x, okay, minus 7y equals, and then when I move the decimal place 2 places here, it's negative 18. Okay? I now have a system that's much nicer to work with. Now I can just use my normal elimination method process where I need to find opposites. I see that I don't have opposites here right now, so what I'm going to have to do is multiply this top equation. I can either multiply by negative 2 so that the x's will cancel out, or I could multiply this top equation by a positive 7 so the y's will cancel out. I'm going to choose to multiply by 7. Okay, either way would work though. 7 times 5x is 35x. 7 times 1y is plus 7y. And then 7 times 9 is 63. We've got to remember to multiply all 3 parts. Okay, the bottom stays the same. 10x minus 7y equals negative 18. Okay, now we see that we have these opposites, and we're ready to add our 2 equations together. Okay, 35x plus 10x is 45x. The y's cancel out, or they're eliminated. And this equals 63 minus 18, which is 45. Okay, to solve for x here, I divide both sides by 45. So x equals 1. Now, to finish this and solve for y, normally we would go back to one of the original equations. But again, these are these crazy decimal equations I don't want to deal with. So instead, I'm going to just go back to an equation right here, plug in x equals 1, and find out what y equals. No reason, but I'm going to choose the top equation. Okay, just fewer negatives to work with. Okay, so 5 times 1, because x equals 1, plus 1y is the same as just y, equals 9. All right, 5 times 1 is 5, so 5 plus y equals 9. Subtract 5 on each side, so y equals 4. Okay, so now I have the solution to my system, which is 1, 4. All right, so that's a strategy for working with decimals.